There's something odd about the spice harvesters in Dune. This is a civilization that can fold space. They've conditioned human minds to replace computers, and they have energy shields that can stop a bullet. Yet the machine that harvests the most valuable substance in the universe is a giant metal box on treads, and it looks like something from a 1950s mining operation. The obvious answer is the Butlerian Jihad, the war which banned thinking machines. But even without computers, surely they should have built something elegant and efficient instead of a loud moving factory. But they didn't build a bad machine. They built a machine where the thing that makes it work is the thing that kills it. They weren't fighting technological limits. They were fighting Shai-Hulud. Sandworms hunt by rhythm. Any repeated vibration pattern through the sand summons them. The Fremen developed an arrhythmic shuffle to avoid detection. No pattern means no worm. But industrial equipment can't do that. Here's what I discovered about sand. It acts like a giant seismic conductor for low-frequency waves. Real-world desert predators, like the golden mole, don't rely on sight. They sense vibration. Their inner ears are tuned to low-frequency waves moving through the sand, allowing them to detect insects like beetles through motion alone. Now scale that beetle up to industrial mining equipment. You're processing material at scale while moving. Every gear turn and every tread impact sends low-frequency shockwaves through the sand that can be felt for miles. The early harvesters used drag lines, massive excavators that drag a shovel through the sand on a cable. But it turns out that dragging steel through sand generates heat, and on Arrakis this becomes a chemical problem. Frictional heat degrades the spice's molecular structure, so they were literally cooking their profit. Under normal conditions, we lubricate mechanical systems with water or oil, but in the desert, hard silica turns lubricants into a thick grinding paste. And sand is a thermal insulator, so it traps heat instead of dissipating it. Then there's the vibration problem. All that grinding and dragging creates sustained rhythmic patterns, which summons the worm. So the drag method was abandoned fast, not because it couldn't move sand, but because it turned out that the sand was ecologically weaponized. The next generation tried to eliminate friction entirely with vacuum extraction. These were massive mobile factories that used centrifugal pumps to suck spice-rich sand directly into a processing plant. No dragging means no heat, which results in pristine spice. But then they hit a geological wall. The Dune Encyclopedia describes a spice pack, a hardened leathery shell that forms over the richest deposits. A vacuum can't lift a solid shell, so to get the high-value stuff, you have to break it. This is where the engineering hits another trap. In the Dune Encyclopedia, this is handled by separate support vehicles, sand crawlers fitted with harrows that break up the spice ahead of extraction. The 2021 harvester collapses everything into a single form. Along its midsection, between the tread banks, it has these towering vertical structures, which appear to act as stressors, devices meant to fracture compacted sand through pressure or vibration. But this is the engineering dead end. By trying to break up the spice crust, the harvester essentially becomes a giant seismic thumper. Every impact sends a rhythmic pulse through the sand, forcing a choice: stay quiet and harvest the low-value surface dust, or create a rhythmic dinner bell and get access to richer spice. I came across this number in the Dune Encyclopedia: 96.7%. This is the percentage of spice operations interrupted by a sandworm. On Arrakis, the worm isn't a risk, it's the schedule. And I think this explains why the harvester looks like a rusty, primitive box. It's a strategy pulled straight from the Battle of the Atlantic. During World War II, the US didn't try to build an unsinkable ship to transport goods across the Atlantic. They built the Liberty ship. These were simple and cheap. The logic was, build ships faster than the Germans could sink them. The harvester is Arrakis' Liberty ship. In a way, it's designed to be lost. Additional armor only adds weight. Weight adds vibration, and vibration makes the dinner bell louder. The machine will eventually be destroyed, so build it cheap enough that losing one is somewhat acceptable overhead. But this creates a lethal trade-off. To maximize efficiency, all flight hardware is deferred to the carryall. This creates a sort of hub and spoke model, where one expensive flight asset services a fleet of cheaper harvesters. Contrast this with a modern offshore oil rig. Under international safety standards, a rig is engineered for independent evacuation. If the platform fails, the crew has free-fall lifeboats and escape chutes. They don't need a second vessel to save them. Since the harvester has no independent way to leave the sand, the crew is trapped by two specific realities. The machine is too slow to outrun a worm, and the ban on thinking machines means no onboard seismic monitoring, so the crew depends entirely on a spotter in the sky. In the Imperium's math, the crew is on the same side of the equation as the harvester. The machine isn't meant to be disposable, but it is built to be replaced easily. By keeping the harvester primitive and moving complexity to the carryall, the expensive asset stays off the ground. Losing a carryall that services multiple harvesters is a disaster, but a crew of 21 miners can be easily replaced. On Earth, engineering balances safety, durability, and cost. But on Arrakis, the worm collapses all that, so you only optimize for how much spice you can extract before it arrives.